So hi guys, by the way, my name is Muhammad Faidman Alondong, and now we're gonna discuss about the electronic configuration. So what is an electronic configuration? So the electronic configuration is the distribution of electrons of an atom or molecule or other physical structure in an atomic or molecular orbitals. So electronic configuration is also called the electronic structure, the arrangement of electrons and energy levels around an atomic nucleus. So in this video, I'm going to give you a simple introduction on how to write the electron configuration of an element. So let's talk about nitrogen. So how can we write the electron configuration for an atom of nitrogen? So that's how nitrogen looks like on a periodic table. So the higher of these two numbers is the mass number. So this 14 is the mass number, and the smaller of the two numbers is the atomic number, which is an integer. So now let's know about the energy levels. So let me write it first. 1 is 2s, 2p, 3s, 3p, 3d, 4s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, 7s, 7p, 7d. No, this is not one of the. Sorry, I'm wrong. Then in these two, 8s. So these are the energy levels. So the S can hold 2 electrons. The P can hold 6 electrons. The D can hold 10 electrons, and the F can hold 14 electrons. So now you want to write the electronic configuration until you get a total of 7. This. Now, for an atom of nitrogen, it contains 7 protons and 7 electrons. But we're focused on the number of electrons because we're writing the electron configuration. For ions, that number could differ for atoms. You just need to focus on that number. So the number of electrons in this problem is the 7. So E is equal to 7. So here's what we need to do. First, start with 1s. This 1s. So I'm gonna write 1 is to 2. 1 is to 2. Because S can hold 2 electrons. So, and then after 2s, you want to go to 2p, 2s. No. Next is 2s. It will become 2s to 2. Now, next is the 2p and 3s. So the P can hold 6 electrons. So we're gonna write 2p. So the next is the 2p. So p can hold 6 electrons, but we only need 3 more. So because if you add the exponents, these 3 exponents, 2 plus 2 plus 3, so it will become 7. So once you get up to this number for atoms, you can stop. This is the electronic configuration of an atom of nitrogen. So 1:2, 2s22, 2p3. So this is the electronic configuration for nitrogen. So what about ions? So let's say if you want to write the electron configuration of the Fe plus 2. Now on periodic table, if Fe has an atomic number of 26, and average atomic mass of about 55.85. So this is what it looks like on a periodic table. So an atom of iron metal has 26 electrons. So an atom of iron metal has 26 electrons. So what about an ion of Fe? Because the charges plus 2, that means the atom lost 2 electrons. So therefore, the Fe plus 2 ion has 24 electrons. So it has 2 less than this number. So we're gonna write the electron configuration based on the number 24. So let's make our list again. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, then 6s, 6p, 7d, 6d, 7s, 7p, then 8s. So as I've said earlier, S can hold 2 electrons, P can hold 6 electrons, and D can hold 10, and then F can hold 14 electrons. So what we need is 24. So by the way, we're gonna write it 1s to 2, 2s to 2p6. So by the way, this is how you arrange the pattern in these sub levels or energy levels, just like this. So that is how the order. So right now we just need to total this electron configuration of this atom. So 2 plus 2 plus 6 is equal to 10. Then 2 plus 6 plus 2 is equal to 10 also. So we need more 6 electron to get to 26. So after 4s comes 3d sublevel. Now I can hold up to 10. Now D can hold 10 electrons, but we only need 6 more. So I write the 6. So this is the electron configuration of Fe, but not Fe plus, 2. So here is the total of 26 electrons. So now from this expression, you want to write the electron configuration of the Fe plus 2. So the electron configuration of Fe plus 2, so we need to remove 2 electrons. So the question is, which 2 electrons do you remove? So now what we need to do is to remove electrons from the highest energy level. So that's the fourth energy level. So you're gonna take these 2 electrons. So therefore the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, then 3d6. So you might be inclined to write 4s2 and then 3d4. And I won't be correct. So when you're dealing with the transitional metal ions, it's better to write the configuration of the parent atom, the 24, and then first, and then if you have the positive charge, this Fe plus 2, then simply take off 2 electrons that's equal to the charge starting from the highest energy level, which is the 4s. So I think that's